Hey everybody, and welcome to Journey into Tech. So happy to have you for a full week. We touched everything from application engineering to software engineering and all things in between. I'm Dom, your host for tonight, and we have a very special guest for you. Just want to say thank y'all all for popping out and showing love. It's through y'all that we're able to do these community events, so we really just appreciate y'all taking some time, especially on a Friday, to come and really try to learn more about this event. But y'all didn't come to hear me ramble on and talk. Y'all came for our special guest tonight. So before we bring him up on stage, I'd like to take the time to give you a little knowledge about Jesus Galvez. Jesus is a software engineer who works on the systems behind Apple's first-party financial services, such as Apple Card, Cash, Pay Later, and other related products. Prior to working at Apple, Hayes has worked on high volume, high throughput operating system Z slash transaction processing facility at IBM. This system serves as a core for transaction processors for several large scale enterprises and industries, including Visa, American Express, Citigroup, Delta Airline, American Airlines, Marriott, and many others. So, to say, we have a titan in the room with us. So I want us to make some noise and give a little shout out to Mr. Jesus as he comes to stage now.
Hello, everyone. Thanks for joining, and I'm so happy to be here. And thanks, Dom, for the fantastic introduction.
Oh no, thank you for taking, the time to come out and just really do this for us and like really share your knowledge. But before we get into your presentation, just want people to learn a little bit more about who you are.
Yeah, absolutely. I guess I'll get into the presentation itself, just to kind of get into the whole flow of it, because I talk about my background there. Um, but really, I'm an engineer. I've been doing this for quite some time, and I'm going to walk through a little bit of that journey. And the main thing that I hope you get out of this is that it doesn't matter where you are in this journey. Everything is possible when you set your mind to it. And hopefully, with resources like this, you can find avenues of inspiration and resources that actually help you get to where you want. This may be an avenue for you. And if it isn't, that's good too. You'll find some other avenue that actually fits you better. And hopefully, this gives you some context as to what the world of cloud engineering looks like. Yeah, so I'll do my best to kind of walk you guys through that.
Nah, he's gonna give y'all a lot of information, so I'm gonna take myself off so he can get on.
All right, fantastic. So this is Cloud Engineering Journey into Tech, and my name is Jesus Galvez. So I'm going to walk you guys through a set of areas, and I'll start first with my background, and I'll spend some time there to give you guys a bit of context as to how I landed to where I am now, and some of the things that influence the work that I do now. We'll go into cloud engineering and what is that. A lot of times the word cloud gets used, and people are like, "What is cloud? Is it in the cloud? What exactly is cloud? What is engineering?" So I'll take some time to dive into what is cloud, what is engineering, and also how it gets used in the world today. And I'll use some real examples of things that I've actually worked on, and things that I've worked on in the past. So to give you guys some context of how cloud is used today. We'll talk about stakeholders, the people I work with, the people who help mold and shape the products that come to life that make your lives easier, and help you connect with others. Some of the essential key things that you know generally common across the board, either skills, soft or hard skills you likely need to be successful in this field. And I'll leave you with some set of guidances, some best tips, tricks, and things to consider as you venture into this role. And again, the idea here is to give you a good perspective, a starting point for you to continue on this journey. If this sounds exciting to you, it's interesting. Hopefully, these tidbits will help guide you to the next step in your journey. So we'll start with my background. So as you'll see here, uh, my journey to where I am today was not a very straightforward path. I took a lot of different avenues, a lot of different roads to get to where I am today. And I think that's kind of like the beauty of my journey. It's that it's non-traditional, as I assume maybe for many of you that will be the case as well. I started my general working career at a nonprofit, working with inner city youth, developing technology curriculum, teaching kids in the city, in the Bronx and nearby boroughs, how to essentially put together websites based on their experiences. I did that for 7 years. Kids learned all sorts of things from HTML, CSS, learning how to take pictures with DSLRs, digital cameras, learning to record the experiences and videos, and learning how to put together these stories using Final Cut. And eventually this group of kids, roughly 8 to 12 of them, would get together for a period of 2 weeks, put together this experience. Some would separate and do some video, some would do Photoshop, and some would actually work on putting together these websites where this whole experience would be hosted. And I did that for about 7 years, and it was a fantastic experience. And it even came back full circle later on, and I'll kind of allude to that a little bit later. But after that, I realized that I really liked the process of not just teaching inner city youth how to use their skills to build websites and learn how to program. I realized that I also like doing the work itself too. And at the time, I was an undergraduate in chemistry. A little later in my career there, I was an undergraduate in chemistry, and I made the decision to switch to computer science, particularly because I saw myself outside of schooling, spending time on the weekends, essentially programming. And it was sort of like a good sign for me to say, maybe this is where you want to go. Maybe this is the thing that, if it keeps you up at night, you're thinking about it, you want to follow that path a little bit. And so I decided to switch careers a bit, moved over to the computer science department, and ended up minoring in mathematics and philosophy. That's a whole different story, but my undergraduate degree was in computer science. After my undergraduate, I went on to work at IBM, which was a fantastic experience because there I got to work on a fantastic organization with a great group of people, incredibly highly technical people, working on what's called the transaction processing facility. And there's a great story there. But I spent 8 years at IBM working on that operating system across different areas of the system. And I learned a lot. There was a lot more that I could have learned for sure. There's a large scope of the system. And I got a little bit of taste of a lot of different parts. And I'll talk a little bit about that and the influence it has today in the world and why it was so awesome. And around that time, while I was at IBM, I actually came back to teach at the alma mater, Lehman College. And I taught there for a year as an adjunct lecturer in the computer science and mathematics department. And that itself was also a fantastic experience. After a while, it was kind of hard to kind of travel 2 hours to teach and then go back to work. So I could only do roughly a year of that, before things got a little bit more complicated. My responsibilities grew, and I had to choose. I became a team lead, and it was much harder for me to take the time to actually go down from Poughkeepsie to the Bronx and actually teach at Lehman. And after some time at IBM, I got the opportunity. It was actually happenstance. I decided to apply to Apple, and lo and behold, got a call back the next day, and there started the journey where I joined Apple Card. And from there, I ended up working on a few other projects internally. And today, I still continue to work on Apple Card and some of the other projects that Apple first-party products has. So I'll get into some of the details, but this gives you a little bit of an idea of sort of my background. It's very diverse. I've taken a lot of different roads, but all of it sort of leading towards a direction. So I hope some of this gives you a sense of it is okay if you take a detour and you want to change. Every day is another opportunity to grow. So, all right. So at IBM, I got to work on this fantastic operating system called Transaction Processing Facility, which is engineered for high volume, high performance, and high reliability of real-time transaction processing. What does that mean exactly? What is high volume, high performance, and high reliability? High volume means thousands of transactions per second. High performance, it has to be really, really fast. right? And in a matter of seconds, it has to actually execute transactions, and it has to be reliable. Every time you use it, it has to function and it can't fail, because it's critical transactions that go through it. And I'll dive into some examples. Um, but that's the essence of this operating system that I worked on. It's one of IBM's 4 operating system. There are others. The main one being ZOS, which is what pretty much most banks use to keep all your data secure and to make sure your accounts are doing well. ZTPF was specifically created to solve this particular problem around reservations. There's a great story there that goes back to the American Airlines and the problem that they had back in the 60s, where when anyone wanted to sort of book a flight, you had to call an agent. And that agent had to look in a sort of Rolodex of sorts and sort of find spots for you. And you would go to the airport and kind of hope that there was a seat for you. And sometimes there was none. And so this was a problem that they needed to solve. How do we reserve seats for individuals and passengers and make sure that no matter where in the world you are, when you speak to an agent, there is a seat reserved for you? And that started essentially the main area of transaction processing, and essentially created what we call today is the e-commerce world. Without that system, we wouldn't have e-commerce like we do today. And it serves as the backbone today of several of the largest financial institutions and the majority of the airlines, rail, and hotel reservation systems. I can tell you, before I left IBM, I was working with Delta and one of the migrations they were doing. TPS was going to be the main backbone of their main system, what's called system of record, where basically all the data essentially lives. And some other applications, we're going to move on to the cloud, right? At the cloud, where they were going to have some of that stuff on Amazon Web Services. So, this idea of duality, making sure that we continue to have the safety and security of a mainframe at IBM in that system that's very fast and secure, and being able to have other applications that are not as critical be hosted on the cloud for a majority of reasons. But I'll get to that much later. These are some of the actual businesses that we worked with, and these are some critical ones. Think of a Visa, right? So anytime you use your credit card, that's a Visa, a debit card, that's a Visa. All those transactions end up going to that system. American Express also uses it. It's the foundation of these businesses. It's a central routing system. It's a system of records of where they keep data. And without it, it's kind of hard for them to function and be able to respond to requests as they come through. And I'm sure you guys are going to be able to find at least a single brand on this list. These are all businesses that actually run on a TPF system of some sort. And and there are actually more. I just put a handful here, but there's substantially more. So anytime you think transaction processing, high reliability, a lot of requests coming through, needing to respond quickly, it's kind of hard to beat a system of this nature. And after that, after working on TPF, I joined Apple, where I work in wallet payments and commerce, where we develop the most secure, innovative, and convenient financial products, from Apple Pay, Apple Cash, Tap to Pay, Tap to Cash, which recently launched. It's a really cool feature where you bring your phones together and you can actually send money to individuals just with a tap, which is a pretty cool feature. So if you have an iPhone and you ever want to pay someone, feel free to use that, Tap to Cash. But we also have state IDs, which continue to come on, and every year there's a new state that joins. And I think recently Iowa was announced as a state. So hopefully we'll get one in New York too. I don't know when, but hopefully I won't need to carry my wallet around. Things like student IDs, transit boarding passes, home, hotel, and car keys, and so on and so on. So it's a huge undertaking to be able to transform the way we behave and the way we carry our identifications and credit cards and pay for things. And I'm so happy that I've gotten to sort of land in this career path where I get to continue to work in the space of financial products and transactions, which is, it seems to be kind of like the pattern in my journey. And for those of you that don't know, Apple Card is one of those products. It's honestly, it's one of the best credit cards out there. There's no fees. It's native to your phone. Fantastic user interface. So if you haven't tried it, go ahead, give it a shot, apply. And I promise you, there are a lot of features that you probably don't even know exist. So dig around all these different areas and modules and click on things. But I'll talk a little bit of what it takes to actually build something like this. It's not just engineers putting this together. There are many people that come together to actually bring an experience like the one you see in the screen. And so I'm incredibly happy to be part of this team building a credit card from the ground up that is very, very considerate and really focused on the financial health of the user, or in this case, the customers, the Apple Card users. So finally, we get into what is cloud engineering. In its most simplest terms, cloud is essentially a network of remote computers, systems, and data centers. That's it. That is cloud, right? So what's the big deal? The thing is that this system and network has actually existed for a very, very long time. It's not new. It's just that the marketing for it is. And so cloud is actually a simpler way to explain to someone. It's a computer somewhere out there in the cloud, right? Because how do you explain that there's communication happening from your phone to somewhere else? It seems like ethereal, somewhere out there. You can't really see it. You can't really touch it, kind of like a cloud. But really, what happens is that this information travels through all these different networks and land in different systems and in data centers where these computers are hosted. And, to be able to build these sorts of systems, you need to have cloud engineers, essentially engineers who focus on essentially combining software systems and networks to design, build, and manage the infrastructure and the applications that run on the cloud, or in this case, run in these different computer systems, and how they communicate and essentially function with each other. It's a very complex system of networks, and there are many things that go into it. It's a very, very, it's a growing field. There's definitely many areas to go into. I won't cover all of it. Obviously, we're limited in time, but the goal will be to give you a high-level perspective here. And, thinking about cloud engineering and what it is that we do, I think the best way to get started looking at the fine details would be to look at another presentation that happened a few weeks ago with Angelica Rose. She did a presentation called Application Engineering with Angelica. It's another one of those sessions with Journey into Tech. She did a fantastic job actually talking about what the process is of creating these applications and what it is that it takes to actually coordinate with many different people. And what does it look like to actually write software in this space? And her presentation was fantastic. I also happen to know her. We work together on the same product. So a lot of the things that she says definitely apply in the context of cloud engineering. And so if she worked on application engineering, what's the difference between cloud engineering? Well, the key here is application is a smaller subset of the bigger, larger systems. So you may have multiple applications running in a system. And that collection of systems is considered a network of systems. And that network of communication is the cloud. So Angelica starts us off with a more local view of what it's like to develop an application that runs in these systems. And my role, at least I hope, is to take you from that application running in this system and across multiple systems, across networks. And that is essentially the role that we do. Every time that Angelica is writing code, we're always thinking about the scope of that application, not just running within a vacuum. We think about the implications across multiple different instances of that application, as well as coordination between different systems that interact with that application, and the different communications that go across the network. So cloud engineering is really a broader term to encompass the interactions and behaviors that these applications exhibit and we design for on purpose. Sometimes not on purpose. There's things that fail, and we have to consider those things and improve on them and fix them. But that is the role of cloud engineering, taking that broader view after you've developed this application, you put it into this environment where it can be expanded, it can grow, it can be tailored to demand to support the application or the business that actually runs it. And I wanted to put together a little bit of a diagram to give you guys a view of what exactly is that differentiation between essentially a program or an application relative to a system. So I won't get too far into the details, but really you have essentially the hardware, which is the physical devices. Think about it as like really, really big machines with hard disks that run these softwares. And at the very beginning of it, the very core of it, we have things like bits. These are zeros and ones. And these zeros and ones are kind of hard to read for humans. So we've created what are called instructions. There's some reusable patterns that make it easy for humans to translate English words, for the most part, English words, into these bits that mean something. And we manipulate them. And these instructions make up a set of algorithms that we've created. Some general, common, reusable, essential patterns that we've over the years, many computer scientists have worked in, and language creators have worked to make the life of people who work in this space much easier. Now, I can tell you, working at IBM, that many people back in the day had to work with assembler, and so that is that is a little closer to the hardware. And before that, you had to get a little closer. So over time, we've been making a lot of abstractions where it's much easier over time with these new programming languages that get created for developers and engineers to create applications. And it's with the amazing work that they've done that we've been able to expand on that and make life a little easier and also much faster to develop these applications. So we create algorithms that make it easy to do common patterns. And using these algorithms, we create programs. And these programs are, you can think of them as like sort of little bits of operations, common sequences that occur, that get created. And when you put them together, when they sort of come together for a purpose, you have an application. And that's what Angelica was talking about in her talk. All right. So what is application engineering? And once you have an application created, what happens? Does it run on your computer? Well, after we have the application, we put it through a process where it gets tested. It goes into different environments, right? So we take it from your computer locally, we merge it into a system that is able to take that code, that binary, is able to promote it into different systems internally for testing. And after it's been promoted into, other quality assurance environments where it's been tested, we're ready to bring it to production, where it goes across different systems. You might have some in North Carolina, some in Oregon, some in China, some Europe, where these things get distributed and they run across the board. You may have different regions. So now you have these applications serving different user bases across the board, and that creates a system, right? This is a system of communication, a system of different applications working together, or even the same application working together to essentially solve the problem of servicing the user for whatever the context is of the business or the organization. And these systems together creates a cloud. It's like a cloud of, up in the sky, which communicates back to databases and is able to route transactions from one place to the other to essentially execute the purpose. So I wanted to give you guys an example of something that actually I have some familiarity with because I've worked in some of this as well. And I figured I'd give you guys a little bit of an insight into how paying works, right? This could be, right now I'm starting with Hermes, but it could have been Amazon. It could have been, buying a flight or booking a hotel. It usually starts with a merchant. The merchant is basically the place where you go shop. And that merchant has to have some sort of connection via network to an acquirer who has set up the structures in place to accept payments and be able to make the job of a merchant a little easier when it comes to accepting payments. Because of course, merchants they're not versed in the concepts of cloud engineering. And so the acquirer makes it easy for the merchant to connect to a network. Now, there are other pieces in here. I just wanted to make this much, much simpler for the conversation. But in essence, these are the main 4 pieces. So let's say you go to Hermes, you found a fantastic bag and you want to buy it. It's crazy expensive, but we'll deal with that later. You bring out your Visa credit card and you want to tap, right? So you go ahead, you tap, and let's say it's $1,000 or whatever, maybe even more. Likely it's going to be more. That transaction where you go to the terminal typically takes roughly a second or 2. But the journey of that transaction starts with the merchant, then to the acquirer, which routes the transaction to a network. So the network is essentially Visa. So every time you take out your credit card, there's usually a little logo. It says Visa or MasterCard or American Express or Discover. Those are all networks. Those are networks of computers that essentially route the transactions to different issuers. Issuers are essentially the banks that issued that card. So if you have a Bank of America card with a Visa logo in it, right, it means that it's using the Visa network and the issuer is Bank of America. And so that's how we're able to essentially execute a transaction when you're buying something. This is the process that it takes. And the reason it's able to work the way that it is because you have a system like ZTPF, the one that I worked in for a few years, creating this network for Visa that allows them to route transactions really, really quickly. Now, this is a fun example where you can go to Hermes and shop for something, but there could be other critical situations where you need the system to work. You can't let it fail, right? Say flights, for example, or you're booking a cab and you need to pay for something. What do? It can't be down, right? You need to go somewhere or you need to pay for something and it's critical. This system being reliable and being able to handle the transactions that it does allows commerce to happen and allows the functioning of generally society to function the way that it does. And I'm incredibly happy and proud of the work that the people continue to do in ZTPF at IBM. And I'm glad that I was part of that, a little bit of that history. But it's systems like that that allow those sort of transactions to actually function. Anyway, I'll take some questions towards the end as well if you guys have questions around what this process looks like. But this essentially is a representation of what cloud does. Now, it's not all in the cloud, and I'll talk a little bit about the different kinds of clouds. Okay. Okay. So there's different kinds of clouds. We have a public cloud, and the public cloud is a cloud that uses shared infrastructure, meaning that these are computers that are shared by multiple businesses at once. And I'll show you an example of essentially a company that allows you to do that. It is usually managed by an outside organization. So basically, let's say you want to start Instagram, for example, and you're like 5-6 people who are building this application. You don't have the knowledge base or maybe the capacity or the money to instantiate all these computers and manage them and execute all this code and execute all this maintenance. You're just like 6 people trying to put together this app, right? You can go to an organization that actually handles a lot of this infrastructure for you. That makes it easy for you to load your application and have it be served from different regions and different locations. That's actually the story of Instagram, where just a handful of people got together and being able to leverage a public cloud, were able to have their application grow. They focused on developing a great application, and the organization that they work with to bring that into the cloud helped make sure that they were able to scale. Typically, there's less control because you have to coordinate with this other organization, and you have boundaries as like, what you can't do, where you do have control as to where and what regions you can put it in. It's a bit more complicated to get into the details, but just know that there's a little less control. And it's not usually ideal for highly sensitive data, right? Because if it's accessible by the internet, that creates an opportunity for more risk when it comes to security. And so there's public cloud. Then there's a different kind of cloud, which is the private cloud. This is what you probably think of when you think about mainframes or computers that are dedicated for particular organizations. So think like banks, right? Banks will likely have a private cloud. And for example, Visa has one too. Visa has what's called VisaNet, and it's a private cloud. It's a collection of computers, or in this case, mainframes, that run TPF, and it's dedicated hardware that they buy. They actually go to Poughkeepsie, New York, where I used to work, and they physically go to see these large machines called mainframes, and they pick the next one. The next one coming out, they pick, many of those, and that's how they run their systems. And it's actual hardware they buy, and they install in the data centers, and they essentially upgrade. And they manage that because they have certain key requirements to make sure that they can actually service the type of requirements that their application needs. Now, the thing about that is that they also have more control. Because they manage their entire system, they can choose to do as they please when it comes to decisions around the system and how it functions, as well as encryption and a bunch of other things. And it's usually ideal for highly sensitive data because it's not really accessible. You can have your own local networks that and limit the vector of like potential entries to the system, which is a key piece of having a private cloud. Is it's very hard to get into them, and you want that safety baked into the process and baked into your systems. And so, what are two great examples of that? Well, I know it might look a little similar to something you've seen before, but Amazon actually has a public cloud, and it's one of the most famous ones. It's the largest one as well, where they saw that a long time ago, they were creating these machines to service their bookstore shopping online, and that other businesses could potentially use this structure, the infrastructure they were creating. And so they began to actually make it available. And that became a business. And they started essentially what is now the public cloud as we see it today. They're certainly the leading edge there. And it made a lot of different applications possible that we enjoy today, like Netflix and Dropbox and Instagram. They all sort of started their journey using these public clouds. But then you also have private clouds. One of the main ones is IBM. They still continue to have a lot of influence in many industries. The majority, like I said before, as you saw in that slide, lots of different businesses, large businesses that are constantly getting transactions coming to them, and they need to service them. They're critical. They run these large dedicated systems, and IBM is one of the biggest in the industry when it comes to that. And thankfully, I got to see a little bit of what that looked like. Okay, so having said all that, right, between the public cloud and the private cloud, who does a cloud engineer work with, right? How do we get our work done? How do we actually bring all these great ideas to reality? Well, in my day-to-day, I work with many, many different people across the board. As you can see, I'm in engineering. I'm only one box of a whole conglomerate of different professionals that work on product, design, project management, privacy, and compliance. That is actually a big one, especially at Apple. Privacy and compliance are a key part of the process of every single thing we do. And having worked and currently working at Apple, I can tell you for a fact we take that very serious. There are times that we could ship faster, but we can't. And it is by design because we want to make sure that we're doing the right thing at all times. And more importantly, that we are protecting the privacy of our users and our customers. And I'm glad that we do, because I'm one of them too. Um, and so these are all the sorts of stakeholders that we have: security, fraud. We have internal partners within Apple, and we have external partners that we work with. And that is the case across the board for most businesses. Um, the list of stakeholders might change a little bit depending on what sort of company you end up working at, but likely is going to be the case is some combination of these you're going to have some sort of interaction with on a daily basis. And it's a team effort. It's, as we say internally, is a cross-functional effort. We need everyone involved to give input, to figure out what is the right thing to build and how should we build it. What should be the security mechanisms for it? Are there any privacy concerns that we should be worried about? Are there any compliance, regulatory, and legal concerns that we should worry about? How is the user interface? Does it make sense? Is it going to confuse the users? And what should the product do? What its purpose? What is the intention, right? So we have people whose main focus is to make sure we do the best work across all of these different areas. And that takes a lot of collaboration. So that is a key piece of the work that we do. Angie and I and many others, my teammates, it is a big part of what we do. We're constantly talking to different stakeholders across the company to help drive and actually build this experience for our users. And so as I get closer to the end here, what are the essential skills that you need? Well, maybe it's a little surprising. You're going to need some technical skills, and you're going to need to program. So how much of that? I would say definitely look at application engineering with Angie or Angelica St. Rose. You'll find it on YouTube. But a big part of what you do, the core, is actually programming, being able to, develop these applications and understand the impacts of this running on these different systems. And as part of that, you're also going to have to learn about REST, which is representational state transfer. It's an architecture approach or method, guidance and pattern of how to use HTTP, which is a protocol on the web, to send information and receive information. And it provides a framework, essentially, of how to create these systems and how to best represent the data that is being sent between one system and the other. So learning about REST is definitely key. It's going to, if you work in anything cloud, you're likely going to have to understand a little bit of what REST is. Of course, database management is a big part of it too. How do you store data? How do you retrieve data? So learning the basics of database management and how data is stored and how it's retrieved, the different kinds of database schemes you can have, structured and unstructured. And obviously, when you have this application running, you don't just load it to the cloud and say, okay, I'll come back next week. You have to monitor it. Is it failing? Are people actually using it? Are there errors happening that you can't see? How do you know things are working well? So a lot of what we do as we're creating these applications that run on these systems is to put in logs and to monitor the behavior of this application, just to make sure that we understand if it's functioning as we expect it to. And it is a big part of what we do, to monitor, to be able to see that things are healthy. And then we drive into the interpersonal skills, because it's not just about programming. And I would say probably the majority of my job is spent in the interpersonal realm of things instead of the technical realm of things. Yes, there is a lot of technical things that come into play. We do have a lot of discussions about it. There's a lot of it that is interpersonal too, like problem solving, having grit and resolve, being able to push through a problem, continue to read, to write. Communication, it is a huge part of what I do. I wish I understood that, at least appreciated that when I was in high school. I didn't think I would need it as much, but But yeah, communication is a big part of the work that we do. Being able to communicate with different stakeholders and constantly being able to answer questions, and also to communicate what it is you're working on and what you need to get the project to move forward and things to function as you expect them to. So there's a lot of communications that is part of the work, and of course, adaptability, being able to change. Things change all the time. Requirements change. Um, your teams change. Products change. So change is the constant that we work in. There's always change. So being able to adapt to the changes, being able to be flexible is certainly a key part of being, I believe, successful in this area. There's always going to be change. The industry changes, the product changes, the company changes. So adaptability is key. And of course, it wouldn't all matter without teamwork because you can't do everything yourself, right? Imagine having to make a pencil from scratch. I wouldn't know how to make a pencil, right? So it takes a teamwork, as I like to say, to make the dream work. So being able to work with different people, being able to explain yourself, communication, and to listen is a big part of what we do. And being able to pick up different areas where there's need and also to support others when they need it. And teamwork is a big part of that. And some guidance. Boy, what can I say? There's plenty. I can start by telling you to use the tools available to you. And there are plenty, certainly a lot more today than there were when I first started. And maybe I should have reorganized this, starting with resources and then tools. But I'll start with the resources. YouTube is a fantastic resource. When I first started, when I was in college, YouTube was just starting to be a thing. It wasn't even like people sharing instructional stuff. It was more like funny videos. But now it is a wealth of information. It's so accessible, so available to you. Take advantage of it. There's a site called educative.io. You can sign up. It does cost some money, but the value you get for the resource that you get, it is phenomenal. There's so many courses on many different things, including systems, including programming, with a lot of questions and prompts and examples and actual answers that you can walk through and try to understand. You can use Gemini, you can use ChatGPT to help, start the conversation to learn about something, and then you can go deeper and follow the paths that it, sort of brings out. I wouldn't bet your life on everything that comes out of these systems, at least not yet. But it's definitely a great tool to get the conversation started and to get an initial idea of the subject that you're looking into or you're interested in. And of course, Coursera, which is a list of different courses online you can get for free. So you can certainly use these resources. I've used them all. I tend to use them regularly too. If they're helpful to me, I think they'll be helpful to you. And of course, in terms of tools, actual hard things that you can start working on, I think Python and Java are two great languages you can start with. Pick whichever. Python tends to be easier to pick up. It's also easier to understand. They're both great. I've used both of them. Now, in the work that I do, Java is predominant. Java and Kotlin, which is somewhat similar, are two of the languages that I've used. But in the past, I've used C, C++, and many others. And so, again, going back to adaptability, change is constant. So the key here is once you learn the general patterns, as Angelica mentions in her talk. Can you tell I'm plugging her so much? She did a great job there, and it's also true. Once you learn these patterns, it's about applying these patterns again with different languages, but the ideas remain. And I think a great tool is a laptop. So put that to use, or a home computer. It doesn't have to be a MacBook. I prefer one, and it's not because I work at Apple. I actually had one before I worked there. As a matter of fact, when I was at IBM, everyone had a Windows machine, and I was the only person on my team that had a Mac. And so sometimes people would be like, why do you have a Mac? Like, nothing we run runs on a Mac. So what I would do is I would actually run a virtual machine with Windows on it, so that I could actually do my work, because I just enjoy the experience of a Mac. But anyway, I'll digress. Yeah, so a MacBook I think is great for just about everything, and you can use an IDE, an interactive development environment, where you can actually write code. You can use IntelliJ, Visual Studio, Eclipse, and so on. When I taught at Lehman, I actually had my students like actually code on the terminal using what's called Vim. Um, yeah, so it's honestly you can do anything. You just need a text pad and the ability to write code, and you can actually make it work. And of course, for database, you can get started with like simple MySQL, PostgreSQL, or MongoDB. But this is just a start. And thank you very much for listening. And I'm happy to take questions. And let me know how I can be helpful in your questions or in your journey.
So first and foremost, sensational presentation. I think you took them very differently than Angelica took them on the journey of cloud engineering. So first off, just want to say thank you for that. As you can see, you had Renee who said Angelica is awesome. You had Dan who said networking is key. We did have this question though when they said public, and I know you touched on this in the presentation, but just in case somebody just started watching, just wondering about. They said when you were talking about public versus private cloud, what are some of the public domains versus some of the private domains when it comes to cloud?
Yeah, when I talk about public cloud, these are systems that are available for rent. Essentially, you pay per use. And AWS, Amazon Web Services, is one of them. Azure, which is owned by Microsoft, they run that one. It's another version of that, right? So you can run on Microsoft's cloud, or you can run on GPC, which is Google Cloud Compute. Similar idea. They all have different interfaces as to how you actually load your application to their systems, but the idea is still the same. They're providing you on a renting basis, resources for your application to use, and you pay based on your usage.
Sorry about that. My doorbell was ringing. I didn't want to disrupt with your flow, so my apologies. But no, thank you for taking us through that. So then, I love how you talked about the hard skills and the soft skills. So I want to take a chance, just delve like really deep into that. So, from a technical standpoint, what tools do you use for the cloud infrastructure management?
Okay, so there's different areas that I can go into, but I go into the most basic one. When I'm developing code locally, I use an IDE. So this is where I'm in my computer developing this stuff. Once the application is created, it gets promoted. And at that point, I'm using GitHub. GitHub is essentially a code repository where I can load the changes that I have to the application, and it gets merged into what's called a track or a train, where everyone else has access to the code. And that code gets built and it gets deployed to different computers within our network. And then those applications get loaded automatically. So as soon as my change goes in, my application runs. And as soon as it starts running, I can start monitoring that application using this thing called Splunk. So we have some things internally, some custom stuff we've written to see the request and response. But the simple answer is using Splunk to look at logs. We can see the messages that are coming through. Obviously, we don't get to see the payload. So we don't see the details of like how much you spent, or any that stuff is encrypted. We don't see any of that. And we don't even log that. What we log is essentially a request came out of this computer, went to that computer, and it responded. It was successful. There was no error. And we can try to monitor the essentially what the application is doing and what parts of the different code are being executed. And we can also monitor certain key performance indicators. How many requests got made in a certain amount of time, and then were they successful? And so the tools that we use really depend on what you're trying to answer. Splunk is a big one for login. And we have some baked in stuff that we've made for key performance indicators to see, is the behavior that users are taking with the application what we expect, right? Are transactions for cash working? Are transactions for Apple Card starting to fall, right? And so we use these tools to give us an insight as to how the application is doing.
Oh, amazing. I'm going to pretend like I understood everything, but I do love that you went some more into just into the tool section of it. So then let's switch over to the soft skills. And I think many people, when it comes to just any kind of engineering, I think they think mostly it's just you writing your own code and everything. So, and you talked about in your presentation about truthfully how important is teamwork is when you're building, or rather when you're doing cloud engineering at a company.
Oh, it's so key. As a matter of fact, I can't even check in my code without a team member approving it. So not only do I have to be able to write this code, someone else has to understand it. So I can't do my job without the help of others that not only help me in the process, but also make sure that if there's something that I've missed, they can catch it, right? We're humans. We're not all perfect. At least I haven't gotten there yet. And so we'll miss things. And even though I have a lot of experience, I miss things all the time, right? And so our team members have a different perspective. They may be looking at this code for the first time. And so they'll be able to catch things that because you've been in this code for so long or whatever, you don't see it, and they will. And they'll make suggestions of things that you can do better because they come from a different perspective. This is why having a diverse experience and having different perspective is so critical. And why, some people think, well, what could I bring to the table? Well, you can bring your perspective to the table. So if somebody is like an artist and like, well, I'm an artist, I don't, I probably couldn't cut it in this career. Well, I wouldn't say so. I think your perspective is valuable. I started out as an artist, right? I used to paint. I was a painter. I went to high school and I was going to go pre-med, but then I also was thinking I was going to be a painter and all sorts of things. But your experience, I think, enriches your perspective. And Steve Jobs used to have this, we've seen different presentations from him, but he used to have this idea of, and we still have this today within Apple, where you bring the humanities, the arts, and technology together. And the combination of that creates a very powerful product or outcome where you can bring diverse experiences, diverse thoughts, diverse expertise together to create something new and beautiful. It's why a lot of the products that we've created are the way that they are, is because you bring so many people from different realms and different backgrounds together who are the best at what they do. And so that is very key. And so teamwork is at the core of everything I do. Without my team, I can't even check on my code. And likely, without my team, I would have a lot more bugs, and things would probably fall through the wayside more often than they do.
Sorry. So no, everything that you're saying is true. Everything you're saying is true, and I feel like, especially in tech, like when someone works at a tech company, there's many different moving pieces. So there's many different teams. So even just on your team, when you come to this still has to go to another team to make sure that certain designs or anything can get attached to it, or another team who's doing research about it. So I think happily that you touched on just how powerful and valuable teamwork really is when it comes to this. But I want to also follow up with this kind of with this question I should ask. So, what would you describe as like your most challenging project you ever had to do in cloud, and what did you do to overcome it for someone who's just trying to really get into it?
The most challenging project that I had to do in cloud. Okay. So it's not necessarily a project that was the most challenging,
Mhm.
but I think usually the challenge comes up when you know the least, right? That's usually when it's like you start struggling with things, when you know the least about the area that you're in. And especially if you're changing new roles, you're changing teams, or you're changing scope or domain of expertise, or you're working in a different area that's very new, you're not going to know a lot of things. By definition, it's new. So typically, if you have a really good foundation academically and you understand the subject, the hardest part is understanding what was the intention um, of the previous authors of this code. What did they want to do? What was and why did they make the decisions that they made in the code? There's a reason usually for it. And so you become an investigator of sorts. You have to investigate as to why certain decisions were made. Now, I wouldn't want to say that that by itself makes it the most difficult. It's just part of the process. And there's different aspects of that. So I haven't yet found a single project that I thought was like overwhelming, where it's like, oh my God, this is so difficult. Um, I guess if I were to maybe point one up, it would be maybe at IBM. We were going really, really deep and we're reading memory. So that was at first, I didn't know anything about reading memory. And so when the system is running, it's running on this large computer. A lot of times the system, well, not a lot of times, sometimes if you had bugs in your code, you had like a null pointer, or you were looking at memory that was not accessible to the program, you would take what was called a dump. And so the program would essentially halt. It would dump a lot of the details of memory onto disk, and then you'd have to trace, like, to figure out what part of memory you know, was being accessed that was not supposed to be accessed, right? Um, did you erase parts of memory that you didn't expect because you wrote, the wrong instruction somewhere? So I think, again, it's not a particular project, but it's more like a new area where you're doing something that you've not done before and trying to understand how things functions. What are the tools? What is the best way to get through and actually understand, how to solve this problem? But it's part of the course, right? So, it's part of the process of learning all the time. So I think that's going to be key in anything you do, but it's certainly key in our industry. There's always something new. There's always a new tool, and so being able to be nimble on your feet and adjust and same patterns, right? So you have to break it down. What am I trying to solve? Who solved it before? Who can I speak to? Are there any resources? Is there documentation? And sort of repeating that process over and over again until you get closer to what it is you're trying to achieve.
And that's very important because, as you know, they always say in tech, the minute you start learning, it's the minute that you're just dead in the water at this point. So I think essentially what you're saying is to have that inquisitive mind. You have to like want to tinker and figure out why does this work the way this works, and then how can I add on to this process of making it work, which kind of just builds out the whole scheme of everything.
While not making it worse too, because
Yeah,
sometimes
I mean,
you put in a solution that's like, okay, maybe it solves a problem, but now it's harder for other people to understand what's going on. So you become sort of like a caretaker of this, for the time that you're involved in this area. You become the person who is now caring for this code and hopefully making it better for the next folks that are going to come through and add their lines future in the future. So
yep, and I think that's also a very good point too. Not messing it up. I think we tend to overthink stuff, but that's the human aspect of it, right? Like sometimes stuff has to break for you to be like, okay, even though this works better in one aspect, it makes everything else falter. So we don't need that, and it just continues to breed innovation. So I think that's
correct.
actually a really cool thing.
Absolutely.
Well, we're at time, but I want to thank everyone for showing up. But more importantly, I want to thank you, Jesus, for just showing up and giving a lot of really good information, whether you're watching it live or you're watching on the playback. This was a really great session. You told me a couple of things as someone who kind of wants to learn more about cloud and has been like pushing it off. Like you kind of got my engine going again to where like I want to like now revisit what I already learned and see how much has changed since I've touched it. So just thank you again for on a Friday night, especially because I know it's a doozy, coming out and showing the community some love and just giving them some information. We truthfully appreciate you.
Absolutely. I think the work that you guys are doing in Chanel is marvelous. I'm so grateful that I get the opportunity to come on these sessions and to share my experience, and that you guys create the space for us to continue to share the knowledge and share the wealth um, with all sorts of communities, with the idea of helping us and others, um, you know, essentially mentor others to find their way. I know I had many people in my life that helped guided me, and I know that there are many people who don't have access to that. So I appreciate you guys for having these opportunities and these meetings where we can kind of mentor different people and help guide them in many ways. So I hope this was useful. Take a look at some of the resources that I shared. The journey is a long one. It's not always straight. It's usually a meander and a couple circles and then an up and down again. But if you stick with it, likely you're going to land on your feet and you're going to be progressing. So have faith and power on.
You heard it from the expert here for us, but thank y'all so much for joining us with this session. I hope we have Jesus again for future sessions. We will. There's a lot of
You
jobs.
bet.
We definitely will. But thank y'all so much. Thank you, Jesus, for coming out on Friday. Thank everybody in the audience. I really appreciate all y'all showing up, and I can't wait to see y'all for the next series. Till then, everyone have a fantastic weekend.
Bye-bye.